Okay, so this is the second video. I'm going to continue on to talk about velocity and um, into velocity and speed. Now, so we talk. So as you notice here, speed and velocity. Now, keep in mind these two are very two different symbols, and you always must keep the case lower or upper or lower case the same. Okay, so this is one of those few cases where you have speed is a lowercase s, and then the velocity is a lowercase v with that symbol on top. Now, both of them have the same unit, so both have meters per second as unit. However, just as we said earlier, velocity is a vector, so it has a direction involved. Speed does not. Speed doesn't care which direction you're going. They just care how the distance that you traveled. Okay, so the formula look like this. Now again, if you are those people who like triangles, you can always do a triangle. So here on the document camera, you have so either S, D, and T like this, or you can have now velocity. I've usually I've seen it like this, so it's this displacement over time. Okay, now time is scalar. We don't move forward and back in time unless we figure out a way how to do that. Okay. Um, okay, so the problem one, the ride that Joey and Heath took 154 seconds to complete. So speed will be this. The distance divided by the time, that will give you this number. But if you calculate the velocity of the whole ride, now keep in mind from earlier, your displacement is only 24 meters east. Basically, from the beginning of the ride to the end of the ride, they only move 24 meters east. That's it. So in this case, 24 meters divided by this gives you 0.16 meters per second east. Okay, that direction. Now, the problem number two. Maria, Alyssa, and Phoebe riding a new roller coaster, moved them 122.3 meters north, which took 45 seconds, and then 122 to 0.3 meters south, which took 75 seconds. So draw a diagram. Okay. So in this case, I'm going to use a document camera. So now document camera. Now in this case, you're talking about north and south, and at the same time, just like the earlier notes, what is it? Up and right, north and east have positive value, down and left, south and west have negative value. So normally what I do is I just draw a scale like this just to show to whoever it is that is reading this note. This is what I use for positive and what I use for negative. Okay. So in this case, you are talking about blah blah. So a roller coaster and move them. So a roller coaster. Let's just say that's a roller coaster. So let's just say that's a roller coaster. It moved 122.23 north. So it goes this way, 1222.3 meters north, and then which took 45 seconds. 45 seconds, I wrote that down here, and then moved down here back to the same spot, 1222.3 meters, and this time it took 75 seconds. Okay, so that's that diagram. And in physics, if you can draw a diagram accurately, it lowers the level of difficulty of a problem by a lot. Okay, so always learn how to draw a proper diagram. So that's a diagram. A, calculate the total distance traveled. So in this case, if you look at this situation, you distance, keep in mind, is a scalar. So you don't care about where they end up. They just care about the journey. Okay. So in this case, it's going up this way and it's going down this way. So there's just 1222.3 plus 1222.3 gives you really double that number, 2444.6 meters. Okay. And B, calculate their displacement relative to where she started. So in this case, she went up this way, she went back down, pretty much the same location. So really, again, keeping the sign. So north is plus, this is minus. So it's really plus 1222.3 meters minus 1222.3 meters, i.e., 0. She has not moved at all. Okay? Since it is 0, you really don't have a direction. Okay, end up in the same spot. So calculate the average speed over the whole ride. So C, average speed over the whole ride. Oh, I will have to pause for a second and power up, plug in the laptop. Okay, I'm back. Plugged in the laptop. Hopefully, the laptop still doesn't die on me. So, calculate the speed. So, in this case, I know speed equals distance over time. So in this case, the distance is 2444.6 meters. Now, let's see how long it took. It took 45 seconds plus 75 seconds. That really means it took about 120 seconds. Okay? So time is 120 seconds. So you divide this whole thing by 120, which should give you, what is it? 2444.6 divided by 120. This should give you, come on now, 20.3716. So, since it's one decimal place, let's keep on one decimal place. So it's 20.4 meters per second. Okay? Now, that's C. B, calculate the average velocity over the whole ride. So, in this case, average velocity. Now, this one is simple. Your displacement divided by time, but since the displacement was 0, so 0 divided by 120, which is just 0 meters per second. That's a velocity. Now, calculate their velocity over only the north traveling part of the ride. Okay, so in this case, north traveling part of the ride. So if you only look at this situation, they only went up north in this section of their travel. So this is D, this is E now. So E is distance, is still the same equation. Now, in this case, your distance is plus or positive 122.1, yeah, positive 1222.3. Now it took 45 seconds for this to drive. So in this case, you divide these two together. 1222.3 divided by 45. So in this case, you have 27.1622, which say one decimal place. So in this case, it's plus 27.2 meters per second. Now, keep in mind, this is a vector now, so you do need to give them direction. And since this is only the northern part of it, so you can say north. So you write north. Okay? Although having the sign here like this, and if you've done this part earlier, it tells me or the reader a sense of direction too. Okay, because it's positive and you indicate in the beginning of the question, north is positive, south is negative. Okay, so that's it for now. Any pause? Any questions? If you don't have any questions, you will need to do this homework here. So basically, look up these ones, and for homework, watch the 3 roller coaster video, fill in the following charts. Okay, so that is for the homework, and have a good day.